In section 1.2, we're going to talk about parallel and intersecting lines and planes. So our first piece of information is that if two lines intersect or cross, then their intersection is a point. And we talked about this with our definition of a point. We said that when two lines come together, it creates a point right in the middle. And here we have point A. So this is our intersection. No, and it's kind of just like an intersection on a road where two roads come together. That point is the intersection of the roads. So then we could say here that line M, which we labeled our line with a lowercase letter at the end. So you can label a line with 2 points, or you could label it with this M at the end. So we could say line M intersects line S. So here we have line S at the end. That lowercase s is not a point, it's labeling our whole line. Line S at point A. We know that A is a point, it's a capital letter, and it's right in the middle where those two lines intersect. Our next point, if we have two planes intersect, then their intersection is a line. So if we have this plane drawn for us already, if we drew another plane that was crossing it or intersecting it, it would look something like this. So I'm actually going to make this part dotted here to show that it's in the background. It's going back behind that point. So this plane, we called it W, Z, Y, point Y up here. Our intersection of this plane would be line WZ. Or say a line there. So a line, two arrows on each side. Line WZ is the intersection. Our next point down here says that parallel lines are coplanar lines that do not intersect. And our symbol that goes in these little parentheses here are two parallel lines. These two lines are the symbol for parallel lines, and they are lines that never cross, never intersect. So they are right next to each other the whole time. The second piece to that is that segments and rays are parallel if the lines that contain them are parallel. So if we looked at two parallel lines, I'll draw them down here. One line here, one line here. If these lines extended forever, they would never touch. They would be right next to each other the whole time. Now, if we said these two lines are parallel, and we had put a little segment on here, let's do it in a different color. This segment right here, and this segment right here, we could say those are parallel because they're on parallel lines. That's what that second piece was saying. Okay? Now, the other thing I want you to know about parallel lines is sometimes it might not say lines are parallel, But if there are arrows like this on our parallel lines, those symbols right there mean parallel. Okay, so now let's look at an example. This one says name all the lines parallel to AB and to BD. So let's start with AB. AB is a line, and there should be lines above our AB and BD up here. So AB is parallel. This is my AB line. If I look, this line down here is next to it and is never going to cross if it extends out forever. So I can say AB is parallel. I'm going to use my parallel symbols here to CD. And I can do the same thing for BD. My line BD, which is right here, is parallel to AC. This is the other line that's next to it and is never going to cross. So I can write AC with my line above it. Okay, let's look at our next piece. If two planes do not intersect, they are parallel. So just like parallel lines, we can have parallel planes. They are straight across from each other, and no matter what, they're never going to touch. So here, our lowercase letters label our planes, so we can say plane A is parallel to plane B. Another type of line we could have is if we have lines that do not intersect, so like parallel lines, they're never going to touch, but they're also not parallel. They're not right next to each other. Those are called skew lines. And if we want to look at an example of skew lines, if we have this rectangle right here, so you could imagine it was a box. If we look at AB, which is drawn in for us already, AB across the top, a line that is skew, that is not parallel and is never going to touch AB, would be CD right here. If we extend CD out, it's never going to touch AB, but it's not going in the same direction as AB either. It's going in a different direction, but it's never going to touch. So we can say that AB and CD are skew. Okay, so let's look at another example. And it is asking us to name some of the following things we just talked about. So our first one says all the segments parallel to AB. So AB means that it's going to be going in this direction, and it's never going to touch AB. So if I look straight down, CD is straight across from it. CD is never going to touch. So CD is one example. Now I could go across the other direction. If we have AB and EF, those are also parallel. EF is another segment. And then my last one I have is this line down here. And it's kind of hard to tell. This B is this point right here. So this point in my back corner is actually point G. So that is segment GH. So I have 3 segments parallel to AB, never going to touch and going in the same direction. Okay? The next 2 segments that intersect CD. So now I'm looking for something that's going to run into CD. So if I start on my CD line, I see that DH meets CD at the corner, so that one's going to intersect. And another one that runs into CD is going this way, BD. So it looks like G, but remember that G is in the back corner. This B right here is my point right here. So I have DH and BD. Now there's more that run into CD. We have AC over here, or CG on the back stretch of the box here, but it just asks for 2. Now the next part, a segment skew to AC. So I'm going to erase these lines here so we can see more clearly what we're doing next. Now this point back here is point G. Segment skew to AC. So we've got AC here, and we want something that's not parallel, so it's not going up and down, and it's never going to touch AC. So all these lines on the front of our box, AB, BD, CD, none of those are going to work because CD and AB, those touch AC. And BD over here, that's going in the same direction, so it can't be that one. So let's look at some of these others. If we have DH right here, it's not going up and down, so it's not going in the same direction as AC. And if we imagine stretching those lines out forever, they would never touch. So a segment skew to AC would be DH. And again, you're going to have other options. We could have chosen BF or EF or GH. So as long as you find one of those options, that's never going to touch and is not parallel. Our last one is a plane parallel to plane ABCD. If we have ABCD, that is the front of my box. So I've got ABCD. It's this whole plane right here on the front. Now we want a plane that's in that same position, but just a little bit further away. So if we look here, GEFH, this plane here is going to be parallel. It's going to be right on top, but it's not touching. So that would be plane EFGH. Okay, we've got 2 more examples, and this next example asks us to write a description of this figure. And so first I want you to write in these little arrows on my lines. This is some given information. I'm giving this piece to you. Let's draw a better arrow. Okay, so if we want to write a description of these 2 lines, those arrows tell me that my lines are parallel. They are right next to each other and never going to touch. So I could write that line M, line M is parallel, so I'm going to use my parallel symbol to line P. That is my description of my figure. Those 2 lines are parallel. Okay, last example, name a pair of opposite rays. So remember, a ray has an endpoint and is going in one direction. So if I have opposite rays, that means I want them going in opposite directions. So I have one ray going this way, one ray going this way. So if I look at my figure down here, if I start in the middle at point A and I go to the right, that is one ray. I would call that ray A, B. Those are my 2 points on my ray. It's starting at A and going past B. So that's the direction I'm going to draw my arrow. A, B, and then I want a ray that's going in the opposite direction. So I could start at A and go this way. So that ray would be A, C, starting at A, going past C. So those are my two opposite rays.